Hello students, in this lecture we will discuss the polar equations for conic sections. So we have already learned the equations of conic sections in previous lectures, but we have considered those equations in Cartesian coordinate. As we have studied the polar coordinates, so now we can formulate those equations in polar coordinates as well. So first of all, we will consider the case of or study the case of a line, and we will see how we can express the line in polar coordinate system. So this line L passes through 2 points P and P naught. The coordinate of the point P is r comma theta, and the coordinate of the point P naught is r naught comma theta naught. Now notice that this line OP and this line OP naught and PP naught, these three lines, they form a triangle, and the sides of these triangles are R naught and PP naught. Also notice that this triangle is a right angled triangle. Now we can express the cosine of this angle. This angle is the angle between the sides R and R naught. So we can express the cosine of this angle theta minus theta naught in terms of the sides of this right angled triangle, which will give us cosine of theta minus theta naught equals R naught divided by R. So this will basically give us the standard equation of line in polar coordinates, which is just r cosine of theta minus theta naught equals r naught. So here the radial coordinate r naught and theta naught is any fixed coordinate in polar coordinate system. So this is our standard equation of line. Now we will consider sort of an example which tells us the polar coordinate of a fixed point P naught, which is whose r0 value is 2 and whose theta 0 value is pi by 3. Now for this line that passes through that the point P naught is, the equation for this line is r cosine of theta minus pi by 3, as this pi by 3 is our theta naught for now, and this will give us, this will equal to 2 because our r naught is now 2. Now we will use the identity cosine of a minus b equals cosine of a into cosine of b plus sine of a into sine of b. We will utilize this identity in this equation. So let us write it down. R cosine of theta into cosine of pi by 3 plus r sine of theta into sine of pi by 3 equals 2. Okay. Now remember that these are cosine of theta and these are sine of theta. This will equal to our Cartesian coordinate x and y respectively. So x cosine of pi by 3. So basically this cosine of pi by 3 is equal to half, and this sine of pi by 3 is equal to root 3 by 2. Finally we will get the equation in Cartesian coordinate, which is x plus root 3 square root of 3 into y equals 2. So this is our equation of line in Cartesian coordinate for the line in polar coordinate, for the given line in polar coordinate. Now consider this circle in polar coordinate system. So this circle has its center at position P naught, which has coordinates r naught, theta naught, and P is any point over the circle whose coordinate is r, theta. And we will now try to figure out the circle's equation. We will use the cosine formula for triangle, which will give us a square equals r square plus r naught square minus 2r r naught cosine of theta minus theta naught. So we are basically trying to express this side of the triangle POP naught. So the side of triangle is basically the radius of this circle. So it will equal to the summation of these two sides, which is r, and the summation of the square of these two sides, which is r square plus r naught square minus 2r r naught cosine of this angle between these two sides r and r naught. Okay, so this is basically our equation of this circle in polar coordinate system, but we want to consider some special situations, and the first situation is when this circle passes through the origin. So when the circle passes through the origin, we have when this circle passes through the origin, you can see that this r naught is exactly equal to a. So this is the r naught, this is the distance between the center and the origin, and when our circle passes through the origin, this r naught will be exactly equal to the radius a. So for this situation, we can write and modify the equation as a square equals r square plus a square minus 2r e cosine of theta minus theta naught. Now these a square terms will cancel from both sides, and we will left with r square in the left hand side equals 2a r cosine of theta minus theta naught in the right hand side. So this equation tells us that the circle passes through the origin and it has radius a. Okay, now we want to modify this equation again, and we want to see when the circle is over x-axis. So when the circle center is over x-axis, so this point P naught is the center, and when the circle is on the right side of x-axis and it also passes through the origin, so it basically has coordinate of the center is the coordinate of the center for this circle is the radius value. So this is the radius value a, comma, as you can see that theta is 0 here. So when we are considering any point over x-axis, so the angular coordinate value, so let us consider this case when we are considering any point over the x-axis. So we are basically over x-axis, so this is our this is our axis for polar coordinates. So this is our this is our polar axis, and from this axis we are considering the angular coordinates. So we are on this axis, so our angular coordinate will be 0. We only have the radial coordinates, so any point P on this polar axis will have a coordinate which is this is r, which is r comma 0. So this point has coordinate a comma 0. Now we can write our equation as, so this was actually r equal twice a cosine of theta minus theta naught. So for this case, when the circle is on x-axis, when the circle is on positive x-axis, the equation equals twice a cosine of theta. Now when this circle is on negative x-axis, we will just inverse the direction of r. So we will have a negative r in the left hand side, and this would give us twice a cosine of theta. So we will left with r equals minus twice a cosine of theta for this case, and we will have r equals twice a cosine of theta for this case. Now consider this case when the circle is on positive y-axis. So when the circle is on positive x-axis, it has the radius a, and the angular coordinate is here pi by 2. So we have the equation of circle for this case is r equals twice a cosine of, now consider that our theta naught is pi by 2. So we have finally twice a sine of theta. So for this case we have r equals twice a sine of theta. And for the case when this circle is on negative y-axis, we have, for this case, we have the equation of circle as r equals minus twice a sine of theta. So these are our two equations for the case when the circle is on y-axis, and these are our equations as we have written above, that these are our equations when the circle is on x-axis, and this is a general equation for the circle which passes through the origin and this is a general equation. So the general equation is the first one. We will now try to find a combined equation for the parabolas, ellipse and the hyperbolas. So to find the equation for these conic sections, we are considering this portion of the conic section, and we are assuming that the focus of any of this conic section is placed at the origin of our polar coordinate system. Now we have learned that we can connect any conic section by using the focus directrix equation. So let us write down our focus directrix equation, which says that PF equals E into PD. That means the ratio of PF to PD is a constant which we call the eccentricity of the conic section. Okay, now what is PF and what is PD in terms of polar coordinates? So PF is simply the radial coordinate r, as we can see very clearly from the picture that PF is just r. And what is this PD? This PD is this distance. So this distance is the difference between this distance and this distance. So this is our we can say this is BF. So what is BF? BF is just r cos theta. And what is this distance? So we can call it for now O. So what is OF or FO? This is K. So we can write PD as K minus r cos of theta. So we want to write this as r plus E into r cosine of theta equals K into E. So this gives us r equals K into E divided by 1 plus E into cosine of theta. We can write the equation of parabola or ellipse or hyperbola from this general equation using the specific value of the eccentricity. So as we know that for parabola the eccentricity value must be equal 1. So for parabola this equation will become K divided by 1 plus cosine of theta. And for ellipse we know that the eccentricity value is greater than 0 and it must be less than 1. So we can take any value between 0 and 1 and it might be half. So for half this equation will become r equals K divided by 2 1 plus cosine of theta divided by 2. So, and it finally will give us K divided by 2 plus cosine of theta. Now for hyperbola we know that our eccentricity will be greater than 1. So we can take any value greater than 1 and we can reach the equation of hyperbola for this eccentricity value. So this we can take for now E equals 2, which will give us the equation will become r equals 2 of K divided by 1 plus 2 into cosine of theta. So this basically tells us that it's equation of parabola in polar coordinate, and this is a equation of ellipse in polar coordinate, and this is equation of hyperbola in polar coordinate. Now consider the fact that we are considering an conic section for which the focus is at the origin and for which the directrix is at the right side of the conic section. So it might so happen that the directrix might be in the left hand side. So for that case you will consider the conic section like this one. So you can consider a parabola like this one, or you can consider an ellipse like this one, or you can consider a hyperbola of this one. So for this type of conic sections you need to modify the equation in polar coordinate and you will get the corresponding equation if we consider the sign of the coordinates accordingly.